Good afternoon, students. Welcome to science class on the chapter force. In the previous class, we had studied the derivation for conservation of momentum. Okay, and also we discussed some problems. So today also we'll discuss some problems. First, I'll write the questions. Here. Yes, see here, a girl of mass 40 kg, a girl of mass 40 kg jumps with a horizontal velocity of 5 meters per second onto a stationary cart. Okay, see this point, onto a stationary cart, which means initially that cart is at a rest. Okay, stationary cart with frictionless wheels, with frictionless, just when there is no friction. Okay, frictionless wheels. Then the mass of the cart is 3 kg. What is her velocity as the cart starts moving? What is her velocity? That what is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. Okay. See here. First, I'll take M1 as M1 means mass of the girl, that is 40 kg. Mass of the girl, and a girl of mass jumps with the horizontal velocity. Okay, so horizontal velocity, that is 5 meters per second, and I'll take a u1, that is the initial velocity of the girl. Initial velocity of girl, that is 5 meters per second. Okay, 5 meters per second. Next, so what is her velocity as the cart starts moving? So here we need final velocity of girl, that is v1. That is V1. Okay. Next, I will take M2 as mass of the cart. Mass of the cart, that is 3 kg. And see here, what you will see here, stationary cart, which means that cart is initially at rest. So that cart, that is U2 is equals to 0. U2 is equal to 0. Why it is 0? Because stationary cart, which means that cart is at rest. Okay. Next, board is not clear, sir. Wait 1 minute. So I think board is not correct. So please change your resolution. Okay. Please change that resolution. See here. So U2 is equals to 0. Why? Because initially that cart is at rest. Okay. Next, mass is over. Then here we don't write final. I'll take final velocity of that cart is, I'll take it as V2. V2. Okay. V2 means what? That is the final velocity of the cart. See here. Just think here. See. Here this is a one frictionless cart. Okay. Frictionless cart. See, she is running from here. Just imagine, she is a girl. Okay. Now she is running with 5 meters per second. She jumps into the cart. Okay. So at that time, when she jumped into the cart, now here both that girl and cart both are moving together, right? Correct. So while moving together, final velocity of that girl is equals to final velocity of the cart, right? So here in this case we can say that girl's velocity is equal to cart's velocity. So both are same, right? Okay. Why? Because she jumped into the what? Cart. At that time, both cart and that girl both are moving together. Okay. At that time, velocity of that girl is equals to velocity of that car. So that's why final velocities of both that girl and car, the final velocities are equal. So that's why I will take final velocity of the girl as v and the final velocity of v2 also v. Why? Because final velocity of both the girl and car, both the velocities, final velocities are same. Okay. Next, see here. So we know the formula, right? According to law of conservation, before collision and after collision, the initial momentum and final momentum are equal. Okay. So that is the m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2 m2 v2. So first we can calculate initial momentum, that is m1 u1 plus m2 u2. Okay, first calculate initial momentum. What is m1? M1 is mass of a gun, right? That is 40 into u1 is 5 plus m2 is 3 kg and initial velocity of that cart is 0. So tell me the answer quick. Here Anupam, Annapurna. Sir, what is mean by u? U means initial velocity. U means initial velocity. Okay, here u1 is final initial velocity of gun and u2 is initial velocity of that cart. Okay. First quick. So what is the answer? 20 kg. No, it's a momentum, right? What is the SI unit of momentum? I think it's 200 kg, right? It's not kg. What is the SI unit of momentum? Yes, your answer is right, but the SI unit is wrong. 200 what? Idli or dosa? What is the SI unit of momentum? Yes, sir, 200 kg meter per second. Very good. Okay, see here, 40 into 5, 200 plus 3 into 0, that is 0. So finally 200 kg meter per second. So this is the initial momentum. I will write here 200. Okay. Now calculate final momentum. That is after collision. See here, collision means what? That girl jumps into that cart, right? Okay. So total momentum before collision, that is 200 kg meter per second. Now calculate total momentum after collision. So m1 v1 plus m2 v2. So m1 is 40 and v1 is we don't know, right? So I'll write it as v, because we have taken final velocities of both cart and girl v, right? Okay, plus m2 is 3 into v, that is 40v plus 3v. So here we can add, right? Because previous is like terms. Okay, that is 43v. 43v. Here you should know this one. Why here we have taken v, capital V and v? Why? Because so when that girl jumps into that cart, right, at that time the velocities of both the cart and that girl both are equal. Okay, so that's why we should take final velocity of both that cart and girl are capital V. Okay. Next, so what is the final momentum? That is 43v kg meter per second. Okay. Yes. So now both are equal, right? Initial momentum is equal to final momentum. So now bring 43 this side. So 200. Tell me the answer. Calculate v. What is the answer? First. Yes, 43 kg meter per second. Correct. So now calculate v. Now calculate v. Yes, what is the answer? Calculate V. That is a 4.6 meter per second. Is it right? Wait, let me check. Yes, correct. 4.65 meter per second. So 200 divided by 43 is equals to V. Finally, we will get V is equals to 4.65 meter per second. Okay. So when you jump into that calculator, at that time her velocity is 4.65 meter per second. So now this is the final velocity of that girl. Then what is the final velocity of that cart? Tell me, what is the velocity of that cart? Quick. Final velocity of that girl is 4.65 meter per second. Then here a stone of 1 kg. A stone of 1 kg is thrown with the velocity of 20 meter per second. The velocity of 20 meter per second across the frozen surface of a lake and comes to rest after comes to rest after traveling after traveling a distance of 50 meter. What is the force of friction between the stone and the ice? ice. Yes, see here. A stone of 1 kg is thrown. A stone of 1 kg is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. So, what is the force of friction between the stone and the ice? So, here our work is to calculate force. Okay. Yes, if you want to calculate force, we need. You know the formula, that is we need mass and acceleration, right? Yes sir, find answer for this question. I will give you 2 minutes time, quick. A stone of 1 kg is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. What is the force of friction? What is the force of friction between the stone and the ice? Yes, do it fast. Okay, so first write the data, that is mass. M is equals to a stone of 1 kg, right? So mass of that stone is 1 kg. Then to calculate acceleration, we need, to calculate force, we need acceleration, right? But here we don't know what is the of that stone. Okay, but how to calculate? To calculate the acceleration, see here they have given some, it's what is thrown with the velocity. So clearly we can say that initial velocity is 20 meter per, initial velocity is 20 meter per second. So here already some students answered. Morning sir, who is this MD Patil? Reddy Meghana, you answered -4 Newton. Wait, check answer for that question. Yes, it is correct. Okay, 4 new -4 Newton. Your answer is correct. Ha. Yes, Shruti, you answered yes, -4 Newton. Yeah, correct. See here. Okay, so U is equals to 20 meter per second. Then see here, surface of a lake and comes to rest after traveling a distance of 50 meter. So clearly we can say that final velocity of that stone is equals to 0 meter per second. Then what is the distance traveled? That is S is equals to 50 meter. Okay, so to calculate acceleration, we know the values u, v, and s. So using these quantities, is it possible to calculate acceleration? See here, we know the formulas. V is equals to u plus at. So here we can't use because we don't know time. So then s is equals to ut plus half at square. Here also we don't know the time taken. So we have one more formula, that is v square is equals to u square plus 2as. Okay, so we can go with the third one. Why? Because here we know the values of v, u, and s. Okay, so now calculate acceleration using third equation of motion. So first we write the formula, v square is equals to u square plus 2a s. Okay, so we need here, right? So bring u square this side, that is v square minus u square is equal to 2a, yes. So bring 2s this side. So v square minus u square divided by 2s is equals to a. Clear? So we can write this formula right here. A is equals to v square minus u square divided by 2s. Okay, So V, that is final velocity, that is 0 minus U, it is 20 square, 20 square, 2 into 50, distance is 50. Okay, so 0 minus 400 divided by 100. Clear? So acceleration equal to minus 400 divided by 100. So that is minus 4 Newton. Minus 4 Newton. Okay. So now substitute here. Substitute here. F is equals to M is 1 and A is minus 4. So finally the answer is minus 4 Newton. And here we got minus. Can anyone explain why it is minus? Yes, sir. Please put answer for this question. So what is the meaning here? We got F force is equals to minus 4 Newton. So what is the meaning here? Okay. What that negative sign indicates? Quick. So minus 4 Newton. So that negative sign, what it indicates? Because 400 have negative sign. What is that? Yes, sir. Opposing force is friction. Yes, Annapurna, you have answered. Anupama Devi, 100. So 400 are negative sign. No. See, my question is, F force is equals to minus 4 Newton, right? Here, what this negative sign indicates? Just tell me that. Okay. See here you throw that stone, right? So after covering a distance of 50 meter, it will comes to rest. Why? So due to that friction force, some force is acting against the direction of that stone. Okay, correct. So here due to that friction force which acts friction force which acts against the direction of the motion of the stone. So that opposite force, right? So here this negative sign which indicates that force, okay, which is in the opposite direction, opposite to the motion of that stone. Clear? Yes. Next one. Here that applied force which is against the direction of that motion of the stone. So that's why here we got negative. The direction of the stone and that application of force both are in opposite direction. Next one. An automobile. Yes, see here, an automobile vehicle has a mass of 1,500 kg. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration? So negative acceleration, here clearly we can say that initially that object, that vehicle is in motion and it will come to rest. If you want to stop that vehicle, so you have to apply force, right? So here what is the, see that force is from the road, due to that vehicle is contact to the road, right? So due to the friction force, that vehicle, it comes to rest. Okay, so calculate that force. Okay, so here mass of that vehicle is m is equals to 1,500 kg, and calculate force fast. Find answer for this question quick. Yes, find answer for this question. Calculate the force. Yes, calculate the force. Minus 225 Newton, 2,505 Newton weight. So all are giving the same answer. So answer to that question is yes, minus 2,550. Yes, correct. Okay. Yes. See here. Mass is equals to 1,500 kg and acceleration A is equals to minus 1.7 meter per second square. Okay. Here the topic comes from motion to rest. So that's why we will get a negative acceleration. So already they have mentioned, right, with a negative acceleration of 1.7 meter per second square. So that's why A is equals to minus 1.7 meter per second square. Now substitute here. Mass is 1,500 kg into minus 1.7. Okay, when you multiply, so here you will get minus 2,250 Newton. Minus 2,550 Newton. Okay, minus 2,550 Newton. Okay. So I will stop here. Tomorrow I will continue the class. Tomorrow also we will discuss some problems related to force.